Thank you guys. Thank you everyone for joining today. My name's Frank Ladonna. I'll be the host of today's webinar. We have a great selection of panelists here today. We have Jeff Rogers here from Sensory. He's our VP of Sales and Marketing. Jeff has been involved and influential in the development and design of hundreds of products over the last 29 years that use speech and computer vision technologies. Jeff's focus on how to implement Sensory technologies into real-world products has played an important role in Sensory's success in the market. Jeff has licensed speech and computer vision tech companies such as Amazon, Google, Honda, Levino, Microsoft, Panasonic, Automotive, Sensory, Samsung, and Zoom, and many more. So thank you, Jeff, for joining us today. We also have Cohen Tucker here from Siemens EDA, the technical solution architect at Siemens. He's focusing on digital twin implementation and innovation for automotive customers through the PAVE360 program, applying transformative technologies to challenges in autonomous and connected vehicles. His focus areas are on functional safety, bringing safety into mixed fidelity modeling techniques, and many more. And then our last but not least panelist here is Daniel Bernal. He's our automotive solution architect at Arm. Daniel, he's focused on developing and enabling Arm-based ADAS digital cockpit and IVI solutions for the software-defined vehicle era. So thank you guys for joining. We appreciate your time today. And if anybody has any questions that you would like to ask our panelists, please feel free to use the Q&A down below and submit those in. And well, we'll get started here. I'll hand it over to Jeff.
Thanks, Frank. Appreciate it. And thanks to Daniel and Konas for joining us today. It's great to have a couple of our key partners with us here today. We do a lot with both of these companies, particularly with Arm, as we run across pretty much every Arm platform there is, from the M0 all the way up to some of the newer platforms that Konas will talk about today. So it's great to have our partners here with us. I think most of you probably know Sensory. Just to do kind of a quick intro to our automotive solution, that's what we're focused on in this webinar today. We wanted to build a complete solution that allows us to make it a lot easier for tier ones and OEMs to design a full assistant into a car. So rather than having bits and pieces, or where some of it's going to run on device and some of it's going to run in the cloud, and you got to have all this architecture to support all that, we wanted to develop a complete solution that can run in vehicle. And when we did that, we realized, well, this is really powerful, and I'm going to show you demos of this later. But there still is some advantages of going to the cloud, particularly today for LLMs. And so I'll show you demos of how we're interacting with LLMs as well. So I want to show you kind of both things. But as a quick intro to Sensory, our automotive solution today is a full voice and vision suite of technologies. So we start with wake word or wake words. And what we're seeing today is many OEMs want to run multiple wake words at the same time. Some for addressing in-car specific commands, as well as going to Siri or Alexa or Google or LLMs as an example. Next to the wake word, we need full speech to text. So rather than relying on specific words or phrases that you have to say, and some of the old school automotive approaches are, you would say media control, and then you'd say what you want, or you'd say navigation, that you would say you want. We want to support just a completely open platform where basically the driver or those in the car can say anything they want to say and have it be recognized and have the appropriate thing happen. Voice and sound ID is important, where we can recognize specific voices and we can interact and respond differently based on the voice that's recognized. We've also added our Face ID and behavioral recognition for things like drowsy driving and distracted driving, and looking at where the driver's their gaze is, those types of things. So we've integrated all this together into a complete solution. It's always on, always available. Our in-car solution runs entirely in car. We don't need power-hungry GPUs and other types of processors to run on. What I'm going to show you today runs completely on the CPU, which is pretty amazing. We've got different sizes as well, so depending on the hardware that's in the vehicle, we can do different things. Complete data privacy and control. Right now, cars are kind of a privacy nightmare, because you get in the car, and whatever you say, if it's recognizing the car or going to the cloud, there's no opt-in where you're like, yeah, I'm okay for Amazon to take my data, or for Google to have my data, or for Siri to do whatever they want to do. Everything that I'm going to show you today with our in-car demonstration runs entirely in the car. So there is total privacy and control. And we leave it up to the OEMs to define whether they want to access that for further updates or improvements, totally up to the OEM. Super flexible, as I mentioned, we run across nearly all ARM cores and a lot and other processors. And I mentioned here the M0 all the way to the 720. Low cost of ownership. Again, there's no cloud infrastructure required for our full in-vehicle solution, and obviously market proven and lots of custom solutions as well. Sensory technologies, we're widely deployed. So we're not new to this. We've been in business many years. We have over 200 key licenses and shipped in more than 3 billion products. The logos on the right side are real customers and real projects, and you can see that we do a lot in a lot of different types of markets. Automotive is definitely our focus today. With a lot of these names that you see here, you could see things, companies like GoPro as an example. These are products that have to work in high noise environments, and with Garmin and their dash cams as an example. Again, high noise environments, and that's what Sensory is definitely known for. So we've built in noise immunity, our ability to spot wake words and then do the speech to text in these noisy conditions is obviously really important here. So our solution today starts with a custom wake word or wake words. And again, as I mentioned, some automotive OEMs today are using multiple wake words to go to different types of services. So we start with a custom wake word or wake words, and we want that to be vehicle specific as well. I think it's strange for vehicles to turn over their name and their brands totally to an Amazon or to a Google or to a Siri as an example. Yes, we can still support those, but also I think it's important that the vehicle have their own custom wake words as well. After that, we have our continuous large vocabulary speech to text. Here it allows the driver to basically say whatever they want to say. And I'll show you some examples of that in just a minute in my demos. Next, we turn it over to our natural language automotive command and control. This is where we basically created a small, it's like a small LLM where we're defining the intent and entity and what, the reaction that should come based on what's being said. And in my demos, I'll share with you some more examples of this as well, some recent experiences that I've had with some of the OEMs that I've met with. After this, we can also do simultaneous voice ID as well. So we can say, yep, I heard the wake word. That was Jeff saying the wake word. And based on that, I can control the temperature of the car, but the kids in the back seat, as an example, can be recognized, but they can't change the temperature in the car. We've also added our facial analytics, gaze and distracted driving, as I mentioned, and then our emergency vehicle detection or sound ID is also being integrated into automotive today, where driving along and using the interior microphones in the car, we can detect if a siren's coming, alert the driver, or in an autonomous vehicle, basically have the vehicle understand that and be able to move out of the way. So here's kind of a map of the progress here. So here's the user over here. They say the wake word, hey car, as an example in this example here. And then they say whatever they want to say. How far can I drive without refueling? So this is our acoustic model right here, which basically supports the language. And today we support over 35 different languages. Then we've created a language model specifically for automotive. Basically all things that somebody might say in the car. And that's really important because there could be some specific things that are specific to the car that we want to make sure that are recognized. And again, this helps produce really accurate results for all things that you would say in car. Then the NLU model, this is where we've created that mini LLM as an example, where here it's like, okay, the person's asking about the distance available from the current gas. And then we've created this action lookup table to make it really easy for tier ones and OEMs to integrate this into a functional product, rather than trying to understand, okay, here's the text that was said, and what do I do with that? Here we're outputting bits of information to make it very easy. And then we can have a text-to-speech output as well. You have 120 miles remaining as an example. This is how we're interacting with LLMs today. So similar kind of thing. Hey car, how long will it take me to drive from Portland to Seattle? So here the acoustic model is again, understanding the language, and then we send everything off to the LLM. So gone are the days where some of the old approaches of the speech recognition companies had to develop all these really complex domains to understand all these different things. No, just throw all that at an LLM, it sorts all that out for us. And so it greatly simplifies the development process. And then, bam, it's approximately 3 hours time. And I'll actually show this demo here in a minute with a live demo of this. I mentioned we have a lot of languages. Here's a quick list, and for everyone that signed up for the webinar, you'll get these presentations as well, so you can see these as well. And then finally, our sound ID, really important for emergency vehicle detection. Right now, we're not defining the difference between a police car, a fire engine, and an ambulance, as an example. We're just alerting to the fact that a emergency vehicle siren was detected. We can alert that on the display. We can also let the car know that as well. Okay, so let me turn it over to Daniel at Arm, and I'll let Daniel share a little intro on Arm. Off to you, Daniel.
Hi, folks. In this new world of software-defined vehicles, these are trends we are seeing, right? Very common amongst the industry. More vehicle automation features, advanced user interfaces, and of course, electrification. These trends are resulting in growing complexity of software, and of course, the insatiable demand for more AI-capable compute, right? Every SoC these days is implementing some type of AI acceleration. That's kind of the norm going forward. So this presents new challenges, right? But it also creates new opportunities for solutions. So in March of 2024, Arm announced its next generation of automotive enhanced technology. So Arm prides itself in the safety pedigree of the technology for automotive, and you'll see it's pretty widely adopted, right? But how does this help you as a software developer, right? This is actually technology that our silicon partners adopt and design into their next generation silicon. This actually includes the first Arm v9 CPU for automotive, and that's the Cortex-A720, and that's what you'll see a demonstration of later in the webinar. So if all the stars align, right, we will see silicon with these new technologies in less than 2 years' time, right? But so you might ask, how does that help you? Well, it doesn't help you typically until you have a way to do software development for it, right? And that's what this webinar is really focusing on today, is how to start software development earlier rather than later, right? And we can do that with virtual platforms, right? So in the automotive technology stack, which is pretty complex these days, right? An example here is every OEM is looking for a virtual platform for software development, right? And the primary reason for that is for functional validation, right? Functional software development and validation of the software. This is what we consider to be the minimum automotive software technology, right? Or automotive technology stack that's required these days. No longer is it just a platform with an OS booted, right? You actually need to support software development way prior to actual silicon, and that's what we're showcasing today, right? So at the lowest level, there's a scalable heterogeneous compute. There's and we call it heterogeneous because those designs these days typically include not only a high performance compute, the Cortex-A compute processor, right? But also some type of safety or real-time compute domain. And sometimes those are discrete CPUs architected into the same platform. So So instrumental to this is early software development support with virtual platforms, right? And the big trend these days is all these are moving to the cloud, right? And on top of that, you'll see operating systems and middleware support, both on physical and virtual platforms, right? But early on, what you care about is development. And so virtual platforms is a huge focus these days. So the webinar will provide examples of how software development can begin ahead of silicon with virtual platforms. And you can see that when comparing the traditional to the traditional serialized software development and systems integration approach, this new world of software-defined vehicles and virtual platforms can easily accelerate software development timelines. I think this slide shows, up to 2 years, but your value will vary based on the platform you employ, right? So what you'll see today is a demonstration of the results on a collaboration between Sensory, Siemens, and Arm. And this will show you how you can develop software for the Arm Cortex-A720AE, which is, like I mentioned earlier, not yet available in silicon, but it is available on virtual platforms. So you may have noticed a new logo in this slide. It's the SOFI Consortium, that stands for Scalable Open Architecture for Embedded Edge. It's an automotive consortium established by several OEMs, tier ones, and software partners, and Arm, right? A couple of years back to drive an open architecture specification for software-defined vehicles. This is being done with open industry standard APIs. And then also you'll see on the right side, there's an acronym called EWAL, Edge Workload Abstraction and Orchestration Layer. It's kind of a mouthful, but nonetheless, it's a reference implementation of the SOFI architecture specification version 1.0. And there will be commercial OSs that also meet the specification. So for more info on that, feel free to visit the SOFI.io website or reach out to me directly. At this time, I'll turn it over to Konos from Siemens to provide more details on the Siemens platform.
Thank you, Daniel. I'll just take over and I'll share my screen. Thank you. So, yep. Hi, guys. Hi, folks. I am from Siemens, and I'll be talking a bit more about the Siemens PAVE360 digital twins. And we will talk about how we provide the virtual hardware and how we can make the software development shifts left and how we make it a reality. Right? What we have done in this case is, well, we have partnered very closely with Arm and the AWS to provide the platform that is needed in this case as well. We provide a platform, which I'll just show you in a minute, on which our partner Sensory in this case will be able to create an application software which would run totally on cloud and can do it without the availability of the silicon. As we heard, Daniel, if all the stars align right, the silicon will be available in 2 years' time. And this is not just anybody. This is the story of the legacy hardware decisions that have been taken and how the hardware is getting sent out to the market in this case. So we provide the virtual hardware on which software developers, application developers can begin and really shift left, because we are in this era of software defined vehicles with codes getting so complex. So that's why we need to do multiple iterations of the codes to get it exactly right. And we need a scalable solution as well. So this is what Siemens is providing in this case. What we provide, and one of the key factors that software developers come is the current technologies are really, really slow. What we provide is we provide near real-time simulation speeds as well. And as it says, we are much faster than current technologies like QEMU. And if we have to put a number on this, we are 20 to 30 times faster as well. and we run natively on the AWS servers, and we can meet your customer needs in this case for the speed. And if you are looking for efficiency, we have other models, other for cycle accurate simulations, we have other solutions as well in which you can accurately um, analyze your software, developed software in this case as well. Just to give you a small context, and I would thank you so much, Daniel, that you have explained what SOFI and EWOL is. I always screw up those words, but thank you so much. What we have given is we have leveraged the cloud resources, and we have just added our secret sauce here. Just as I can use the laser pointer, that would be much nicer. We have leveraged the AWS resources, and we have used the Siemens secret sauce to create a virtual SoC CPU and mapped its interfaces on top of it as well. And we have incorporated the Linux that we use as a reference tag on which our partners can develop apps on. We provide this chamber as an web interface which can be accessed from the PAVE front end. This is an Eclipse based IDE, or you can just go to your browser and access this chamber as well. And this is where your whole application development can begin very, very early in this case as well. And lastly, before we jump onto the demos and everything at the moment, I know you have seen this slide in Jeff's presentation with much nicer colors. I just transformed it to a Siemens part at the moment in this case as well. So when you'll be seeing the demos up next, the demo is running entirely on the clouds. The green big box or the big blue box that you saw on Jeff's slides is running completely on cloud solution. And the audio source is just the laptop microphone or a computer microphone that you want to see. We'll be using, and all the data will be transferred into cloud, in which you'll have the wake word, you'll have the language model, NLU lookup. The magic of Sensory is getting computed, and we just provide the virtual computation platform, and it comes back as an output through your hardware speakers in this case. So with that, I will stop sharing, and I will give the presentation to Jeff in this case, who will take us through the demos. Thank you.
Great. Thank you very much. So sharing my screen here, and on my screen is basically, this is my mobile phone. I'm just screen sharing my mobile phone. So everything you see here in this box is the same that's on my mobile phone. And
Hey,
you can
Jeff.
see that, yep.
I'm sorry, we can't see your screen yet.
How about I actually hit share and I see the green box around it?
There you go. Perfect. Yep.
Yeah. So everything this is my mobile phone right here that you're seeing. And you can see that the microphone's on. I've just got my mobile phone down on the desk in front of me here. So a couple things about this demo. This is our completely in-vehicle demo. So everything you're going to see here runs totally, in this case, on my phone, and obviously can do the same in the car. To start with, lots of different languages that are supported. You can see here the language list, and yeah, this is it's awesome. Next is I've got the domain automotive. There's two options here: general, if I'm just doing dictation as an example, or transcription, that's fine, or the automotive. And in this case, I want to do automotive, where we've actually created automotive language models. Next is the sizes. I've got three different sizes: small, medium, and large. So I've got one that's 253 megabytes, I've got one that's 163, and I've got a really small one that's only 34 megabytes. I'm using the large one here. I could go to the small one as well and expect the same performance. In fact, I'll do that. So now I'm going to switch to the extra small one, 34 megabytes. So everything, so that includes the wake word, the language model, the acoustic model, the simple LLM, and the NLU, the lookup table. Everything in there is 34 megabytes, which is, I mean, it's awesome. We can run on a lot of different platforms. And then here I've got the wake word, kind of our standard wake word here. So now I can basically just talk to the car. So I can say things like, voice genie, set the temperature to 68 degrees.
Setting temperature to 68.
So you can see that this recognizes what I said. This has the NLU output. The intent was to set temperature. The number was 68. As you look at these, the words here, every word that's recognized or spoken has a probability or a confidence assigned to it. So the red indicates a slightly lower confidence. Black means it's very confident. I think it's over 90%. So I just sent the temperature, and then I can say things like, voice genie, it's too warm in here.
Lowering temperature.
So I was meeting with a large OEM a couple weeks ago at a Detroit show, and I was giving this demo, and I was going through kind of the standard things that you can say, and he's like, you know what? Let me just try it myself. I'm like, sure, whatever. So I had we were on my tablet, and it was on a table in front of us, and we're in this noisy conference hall, and this is the thing that he said. He said it's too noisy, or it's too warm in here, and he was just blown away at how easy it was. Why do I have to do all this stuff to adjust the temperature? Why not just say it's too warm in here? And he loved the fact that you can basically just speak to the car like you would to another person, and it recognized. Voice Genie, adjust the wipers to intermediate.
Setting wiper speed to intermediate.
You know, instead of fiddling with the wiper knob and twisting it and doing all these things, just say what you want to do. When I go through the car wash in my wife's car to turn off the parking sensor, it literally is an 8-step process. I have to push a button on the steering wheel, and then I have to push an over button, and then I have to hit select, and then down to parking sensors, then turn them on, turn them off. Why not just say, voice genie, turn off the parking sensors?
Disabling parking assistant.
Let me give you a couple more kind of fun examples here. Voice genie, what's that flashing icon on the dashboard mean?
Showing the driver's manual for the active warning lights.
I mean, this is awesome. This is how voice should be in cars. Voice genie, navigate to 4701 Patrick Henry Drive in Santa Clara, California.
Displaying directions to 471 Patrick Henry Drive in Santa Clara, California.
So it's actually pulling up the map as well, which is pretty sweet. Voice genie, navigate to the nearest gas station.
Displaying directions to the nearest gas station.
And then again, here's the gas station popping up here. Voice genie, navigate to the nearest charging station.
Displaying directions to the nearest charging station.
And it's great that as I'm speaking, you can see the text just instantly hitting the screen. And some automotive OEMs like that. Some just, just pop it up. And we can do both. It's called batch or streaming. Here I'm streaming, so as I'm speaking, it's popping up instantly as I'm speaking. Batch is that I say what I want to say, and then it processes the whole thing and comes up with the solution after that. Voice genie, play Fleetwood Mac Rumors album on Spotify.
Now playing Spotify.
So you can see that the music is this, it's Fleetwood Mac, and the music service is Spotify. Voice genie, dial 408-898-7671.
Dialing 408-898-7671.
You can see it's actually trying to call me right now. And I ripped through those numbers really, really fast, blurred them together, just kind of spoke as I would probably say to another person. Actually, if I were talking to another person, I'd probably have to slow down. We can totally nail it. Voice genie, send a message to Stephanie. Let her know that I'll call her as soon as I'm done with this cool webinar.
Sending message to Stephanie.
And so it's actually ready to send that message. So this is full on speech to text running completely in the car. I mean, come on, this is awesome. This is running the very small 34 megabyte solution that I selected. So let me now, so this is completely in the car. This doesn't touch the cloud. Let me show you the version where we might want to interact with an LM. And so if I pop up this demo here, just give me a second. Sensory chat. Okay. Close this one. So this is our demo where we're integrating. So here what you're going to see is the wake word runs on device, obviously, and the speech to text is all in car. The only thing I'm sending to the LM is just the text information. Why is that important? A couple reasons. One is but there's no biometrics. There's no personal data going to the LM. It's just the text. So that's super helpful to some users. Secondly, it's a much smaller bandwidth requirement to send the text as opposed to send the full audio recording. So those things are going to help reduce cost. Thirdly, because our recognition is so excellent in the car, I can do a really good job there, and I don't have to worry about blocks or missing gaps of information being sent to the cloud in this case. So as I'm talking, it's going to recognize it in car, then just send that text block off to the LM to recognize. So what we've done here is we've created an interface, in this case with ChatGPT, but it could be any LLM. And I've created my own automotive solution, but in this demo, you can create custom ones for TV control or for medical or whatever. It's really, again, addressing the LLM is just a total game changer in a lot of industries, and certainly for this one as well. So here it's on and listening. Again, the wake word is running on my phone. The speech to text is running on my phone. Then I just send off the data. So in my slides as an example, I asked, how long will it take to drive from Portland to Seattle. So let's test that out. Voice Genie, how long will it take me to drive from Portland to Seattle?
Approximately 2.5 to 3 hours, depending on traffic conditions.
That's awesome. Voice Genie, can you recommend a 5-star restaurant in the Portland area that serves Mediterranean food?
Sending recommendations for Mediterranean restaurants in Portland area now.
So again, gone are the days of this complex, we have to develop all these domains and figure out which domain you're going to go to. Just let the LLM handle all those things. Voice Genie, I want to book a reservation at the Cheesecake Factory in Portland this evening.
Reservations made for the Cheesecake Factory in Portland this evening.
Voice Genie, and make that for 7 p.m.
Reservation for the Cheesecake Factory in Portland at 7 p.m. confirmed.
With the LLM, again, you can do this kind of additive thing where it's okay, this is what I want to do. Oh, and I want to add this to it, and it obviously remembers the last thing. So it really makes a complete solution. I can do everything in the car, plus if I want to, I can do these things outside the car. And in this case, I'm not going to Google to do this. I'm not going to Siri. I'm not going to Amazon. I'm doing it with an LLM. Voice Genie, how many miles can I drive on the current battery?
Approximately 50 miles remaining on the current battery charge level.
So in this case, it's it would access the car data in order to understand that. Voice Genie, I need to figure out how to program my garage door opener with my car.
Access the car's manual for programming instructions on garage opener.
So here, I think obviously this is where it would pop up, page 715 that basically shows me how to do that. And again, we could take a user's manual and run it through the LLM, and then basically let the user ask any question they want. What's the tire pressure should be, and how much oil should I put in, and when should I change the oil, and what type of oil, and how do I program my garage door opener, etc. So using the power of LLMs, yeah, it's going to be a complete game changer. Today they're in the cloud. Tomorrow they're going to be on device. So just wanted to show some quick demos there. Let me turn it back over to Konas now to show the demo that they've created that uses Sensory with their PAVE360. So back to you, Konas.
Superb. Thank you so much. So putting up the entire screen and share. So thanks for the lovely demo, Jeff. This was a detailed demo explanation. And whatever Sensory has done on their local devices, we provided them a cloud service and they just got it on the cloud straight away. So just a second. I'll have to just reload once more, and probably this should be good to go. And I believe I have hit some kind of a snag. Hey, Voice Genie. Hello? Voice Genie. Oh, goodness me. Once I'm so apologies, the demgods are not working with me. Seems to be some sort of a trouble on my end. Jeff, do you have this demonstrator up on your side as well?
I don't have this one on my computer. I don't. Sorry.
Oh, goodness me. So just let me restart this and I'll stop sharing for a second.
Yeah, well, while Konas is redoing that, so what we've done here, what they've done is they've taken our cloud solution. So basically, everything that I was showing on device, they're running as a Dockerized container. So we've defined or built the technology such that it allows us to support a Dockerized container. And so what Siemens Automotive is doing then is using that, because in this virtual software development, it allows the developer to create this, do all that development in the cloud without having to worry about, oh, the hardware's not ready yet. And then once it's all developed there, then we can obviously move to the hardware. And sometimes there's a bit of a connectivity issue between, I think, our Docker and and the demo that Konas has here. So hopefully he's
You saw that, right?
yeah, hopefully he's got this up and running.
I think there has been a snag on the connectivity issue. I was just running this demo before we were entering this webinar, and somehow this is not seem to be working now. And this is, I would say, embarrassing.
No, sorry about that. Basically,
Sorry
the
about
demo
that, guys.
that Konas was going to show would look very similar to the one that I just showed with the attachment to the LLM, wherein again, wake word and speech to text all part of running as part of the Dockerized container, and it allows again the developer to utilize that in the development of their head unit or whatever use case they're developing with our speech technologies. So maybe Frank, what we can do is while Konas sees if he can't get that demo running, maybe let's go through a couple of the questions that have popped in here, and then
Sure.
we'll let Konas work on that in the background if that makes sense.
Yeah. So Jeff, I'll ask you the first question here first. Do you support the ability to run multiple wake words at the same time?
Yeah, we do. That's a great question. And as I mentioned earlier in the presentation, we're seeing now that more and more automotive OEMs, they do want to support Siri and Google and Amazon, and we think that's great, because those services can be really important. But we're also seeing that they want to have their own personalized wake word. Again, if I'm driving my car as the driver, and as the OEM, I want people saying the car brand name or the vehicle specific name, and being able to support multiple ones at the same time is important. And in this case, what Sensory is doing is we're being the arbitrator between, was it the in-car solution that's being recognized? And again, with our in-car solution, in this case it was Voice Genie, but it could be the name of the car, and then it's all things in car that I want to do. But if I do want to attach to Siri or go to Amazon or go to Google, fine, that's great as well. And our solution is small enough that we can run multiple wake words all at the DSP level. So we're not even running full time on the AP, which can be more consuming to the system. So running at the DSP level, we can run multiple wake words. Right now, we're typically doing that in sizes that are around 1 megabyte, where again, we're running multiple wake words at the same time.
Very cool. And Daniel, we actually have a question here for you too. What's new about the Arm Cortex-A720AE versus the previous generation processors?
Great question. Can you hear me okay, right?
Yep.
Yeah. So Cortex A720AE is the first ARM v9 instruction set processor for automotive, right? So when we say for automotive, it's designed with ISO 26262 systematics, right, in the development process, specifically for automotive, and it provides the ability to do diagnostic coverage for both transient and random faults up to ASIL B, that's beta, and ASIL Delta, ASIL D for automotive application use cases. But the difference between V8 versions and V9 is there's some unique features for security that are in V9 that aren't in previous generations as well. And plus, every generation or new processor always has an uplift in performance. There's probably a lot more detail I can provide, but please reach out to me if anybody has questions, or if you could do just a search on the web for Cortex A720AE and ARM. you'll see lots of details on our website.
Great. And we'll keep going here. So we got another one in the chat. Can you talk more about the virtual platform? Are these System C models?
So I believe this is one for me as well. What we have is we have leveraged a strategic partnership with Arm, and this is where we use Arm's internal AFM models and we map it to our own resources. And we have capabilities to run C models as well and the TLM models as well as the RTL models. But for the underlying fast simulation technology and the fast execution speed technology, these are specialized created models for fast execution.
Great. Thank you, Konhas. While you're off mute too, I have another question here for you. What is the biggest pain point for suppliers looking to move toward digital twin from traditional design processes?
So what has happened in the world of the cars is we have the legacy tooling. We have a lot of models flying here and there and multiple tools as well. And if a customer wants to develop something with the new technology, they lack of interoperability between these tools and between these models as well. Now, what PAVE360 as a solution is an open platform where you can connect your multiple tools together as well, multiple models with different levels of fidelity as well. So you can have the virtual platform, you can use the emulation as well, you can use multiple sensor models, actuation models, and this is where you can create a composite digital twin, and it can be defined and tailored according to the scope of the project and according to the needs of the end customer in this case as well. So that's how we address the pain point of the current customers and the OEMs that we have in this era.
Great. Great. Thank you. Jeff, if you want to have another one here for you, I think. Why is an in-vehicle assistant important when there's so much power in the cloud today?
Yeah, it's a good question. There's several reasons. Specifically, I'll start with a personal reason. I live in the Portland, Oregon area. There's a lot of hills and trees, and in my house, I've got great Wi-Fi, obviously. As soon as I back out of my garage, I virtually have no connection until I get to the top of the hill and out of the neighborhood. And I'm not far from a cell tower, but with the hills and the trees around, I have no connection. So I've got Android Play in my car, CarPlay, and if I want to give Google a command, I have to literally wait until I'm out of the neighborhood until I get that connection. And so it's super frustrating. Obviously, when I'm in the car, if I want to control something, I want to control it immediately. I don't want to have to worry about, gee, do I have a strong enough connection, or do I have any connection at all? In the U.S., we've got a great network, but there are still a lot of holes. Even, like I said, in the city that I live in, there's holes. In the Bay Area, in Silicon Valley, the heart of technology, it's amazing how many holes there are. And so running completely in the vehicle removes that issue that gee, I have to wait until I get into a better connection spot. But as I mentioned, there's also value to being able to go to the cloud. And so, again, running an LLM or addressing an LLM in the cloud, as you saw in those demos, is pretty powerful as well. And so I think really the solution is having both, but having it completely in vehicle for connectivity, it also means that there's no additional cost, and Sensory solution is not charged by the minute. And so our costing is going to be very different than a solution that relies on the cloud, because those cloud solutions are charged by the minute of use. And so if you have 1 million users that are using it an hour a day, that's going to get really expensive fast. With our solution in car, it's a per unit cost. There is no cloud cost. And then again, obviously, if we want to address the cloud, then that's an option, and it's a different model as well.
Great. Thank you, Jeff. And I know we're at time here, folks. So I think if Konhas, I think there's no luck on the demo so far. So maybe we could just wrap it up here.
I'll just do something. I have an idea. I'll just try for a small test and let's see if it works. Just give me a second.
Sure.
On the last question, Frank, the other aspect of in-car versus cloud is the whole privacy side of things. It seems like it's getting more and more relevant. There are more people that are concerned with, everything that I say is going to the cloud, and it can be used for whatever purpose that the cloud agent wants to do with it. And I think that will continue to grow. There's a lot of privacy rules in Europe. There's a lot of privacy rules in California, and it is spreading. So again, being able to do things in the car means that I never have to worry about the privacy aspect of things.
Yeah, that makes sense. It's definitely a huge topic today with privacy concerns and, being listened to by all different types of, detection points and stuff. So that's, really good from the sensory side to implement that.
So yeah, Frank, unfortunately, I do not have good news at the moment. I think there's a connection issue from my
Okay,
laptop to the chamber.
no problem.
As Jeff already mentioned, and as I already tried to explain earlier in my presentation as well, I'll just be using the microphone of my laptop, and every computation happens on the cloud. That's what we have. Sensory has run their Dockerized containers, and it's not just one container. They have deployed 4 containers. So they have the wake word technology, speech to text, text to speech, and the assistants as well. So they have run 4 containers in parallel, and we can choose which type of assistant to run as well. And whenever you fire one of the containers, it will run, and you can see everything is going through the network. I wanted to show you that everything is going through the network path, and it just reflects what Jeff showed you on the local device is exactly the same on the cloud as well. And if we have to just talk about what Daniel told about software defined vehicles and shift left technology, the magic of sensory that is available on cloud and what we just provide as the base.
Great. All right, guys. That was a really good presentation. Thank you to our panelists here for joining us today, and thank you for your time. Everyone who has attended will be sending out follow-ups with everyone's contact information if you wanted to get into contact with Sensory, Arm, or Siemens. They've made themselves available, so you'll get their information shortly after the webinar, as well as with the recording and some of the slide presentations as well. And we look forward to hearing from you. So thank you guys very much, and we appreciate your time. Thank you.